Welcome to EPG Pathshala. I am Dr. Jaswinder Kumar, Assistant Professor, University Institute of Hotel and Tourism Management, Punjab University, Chandigarh. Dear students, today we will understand the concept of time series analysis, and after the completion of this module, you will be able to understand the basics of time series analysis. You will learn about various trends of time series and you will know about various models of time series. Dear students, let us first of all understand what actually time series is. A time series is a sequential set of data and its points which is measured typically over successive times. It is mathematically defined as a set of vectors xt where t varies from 0, 1, 2 up to infinity and where t represents the time elapsed. We can also call time series as a set of observations made at specified times and arranged in a chronological order. The data of a time series are bivariate data where the time is the independent variable. For example, the tourist arrival in India in different years constitute a time series. Similarly, year-wise outbound tourists can be called as a time series. Similarly, annual sales of hotels and restaurants in any destination can be called as a time series. A time series containing records of a single variable is termed as univariate, but if records of more than one variable are considered, it is termed as multivariate. A time series can be continuous or discrete. In a continuous time series, observations are measured at every instance of time, whereas a discrete time series contains observations measured at discrete points of time. For example, the temperature readings, flow of a river, concentration of a chemical process, etc. can be recorded as a continuous time series. On the other hand, population of a particular city, tourist arrival in a particular destination, production of a company, exchange rates between two different currencies may represent discrete time series. Usually in a discrete time series, the consecutive observations are recorded at equally spaced time intervals such as hourly, daily, weekly, monthly or yearly time separations. Time series data often arise when monitoring industrial processes or tracking corporate business metrics. The essential difference between modeling data via time series methods or using the process monitoring methods can be used for calculating the time series. Dear students, time series analysis accounts for the fact that data points taken over time may have an internal structure such as autocorrelation, trend or seasonal variation, and that should be accounted for. We represent time series measurements with the denotions such as y1, y2 up to y infinity for infinite number of observations. It is useful to set down a statistical model in the form of a stochastic process in time series. A stochastic process can be described as a statistical phenomenon that evolves in time. While most statistical problems are concerned with estimating properties of a population from a sample, in time series analysis there is a different situation. Although it might be possible to vary the length of the observed sample, it is usually impossible to make multiple observations at any single time. For example, one can't observe today's mortality count more than once. This makes the conventional statistical procedures based on large sample estimates inappropriate. Stationarity is a convenient assumption that permits us to describe the statistical properties of a time series. Let us discuss some examples in which time series arise, such as in the studies of economics and finance, environmental modeling, meteorology, hydrology, demographics, medicine, engineering, quality control management, tourism management, etc. The simplest form of data is a long series of continuous measurements at equally spaced time points. That is, observations are made at distinct points in time, these time points being equally spaced, and the observations may take values from a continuous distribution. If we rapidly observe a given system at regular time intervals, it is very likely that the observations we make will be correlated. So we cannot assume that the data constitute a random sample. The time series order in which the observations are made is vital. Let us understand the concept of time series analysis. In practice, a suitable model is fitted to a given time series and the corresponding parameters are estimated using the known data values. The procedure of fitting a time series to a proper model is termed as time series analysis. It comprises those methods that attempt to understand the nature of the series and is often useful for future forecasting and simulation. In time series forecasting, past observations are collected and analyzed to develop a suitable mathematical model which captures the underlying data generating process for the series. The future events are then predicted using the model. This approach is particularly useful when there is not much knowledge about the statistical pattern followed by the successive observations, or when there is a lack of a satisfactory explanatory model. Time series forecasting has important applications in various fields. Often valuable strategic decisions and precautionary measures are taken based on the forecast results. Thus, making a good forecast, that is, fitting an adequate model to a time series, is very important. Over the past several decades, many efforts have been made by researchers for the development and improvement of suitable time series forecasting models. Dear students, let us understand various uses of time series. The analysis of time series of great significance not only to the economist and businessman, but also to the scientist, astronomist, geologist, sociologist, biologist, research workers, etc. for various reasons, such as time series helps in understanding the past behavior. By observing data over a period of time, one can easily understand what changes have taken place in past, and such analysis will be extremely helpful in predicting the future behavior. Time series helps in planning future operations. The major use of time series analysis is in the theory of forecasting. The analysis of the past behavior enables to forecast the future. Time series forecasts are useful in planning, allocating budgets in different sectors of economy. It helps to evaluate current accomplishments and then making future projections. The actual performance can be compared with the expected performance and the cause of variation can be analyzed. If expected sales in a particular year of a particular commodity and the actual sale are varying, then the difference between expected and actual can determine the reasons of these changes. The time series facilitates comparison. Different time series are often compared and important conclusions are drawn therefrom it. The objectives of time series analysis. Time series analysis helps in description such as summary of statistics, developing graphs, etc. It helps in analysis and interpretation and to find a model to describe the time dependence in the data, such as can we interpret a particular model. In forecasting or prediction, for example, given a sample from the series, forecast the next value or the next few values. To make the controls, such as to adjust various control parameters to make the time series fit closer to a target. To make certain adjustments, such as in a linear model, the errors could form a time series of correlated observations and we might want to adjust estimated variances to allow for this. Dear students, let us understand various components of time series. The values of a time series may be affected by the number of movements or fluctuations which are its characteristics. The types of movements characterizing a time series are called components of time series or elements of a time series. There are 4 types of components or trends in the time series. These are called as secular trend, seasonal trend or variations, cyclic trend or variations, irregular trend or variations, secular trend. Secular trend is also called long-term trend or simply a trend. The secular trend refers to the general tendency of data to grow or decline over a long period of time. For example, the population of a particular country shows a definite change in its tendency. The death rate in a country after a particular span of time shows some sort of tendency because of certain reasons. Long period of time does not mean as several years. Whether a particular period can be regarded as long period or not in the study of secular trend depends upon the nature of data. Mathematically, the secular trend may be classified into 2 types. Number 1, the linear trend, and number 2, the curvilinear trend or non-linear trend. If one plots the trend values for the time series on a graph paper and if it gives a straight line, then it is called a linear trend. That is, in linear trend the rate of change is constant, whereas in non-linear trend there is varying rate of change. The seasonal variations or trends. Seasonal variations occur in the time series due to the rhythmic forces which occur in a regular and a periodic manner within a period of less than 1 year. Seasonal variations occur during a period of 1 year and have the same pattern year after year. The period of time may be monthly, weekly, or hourly, but if the figure is given in yearly terms, then seasonal fluctuations does not exist. There occur seasonal fluctuations in a time series due to two factors. Number one, due to natural forces, and number two, man-made convention. The most important factor causing seasonal variations is the climate changes. Climate changes in the climate and weather conditions such as rainfall, humidity, heat, etc. act on different products and industries differently. For example, during winter there is greater demand for woolen cloths, hot drinks, etc. Whereas in summer, cotton cloths, cold drinks have a greater sale, and in rainy season, umbrellas and raincoats have greater demand. Though nature is primarily responsible for seasonal variations in the time series, customs, traditions, and habits also have their impact. For example, on the occasions like Diwali, Dashera, Christmas, Eid, etc., there being a big demand for sweets, clothes, etc., and there is a large demand for books and stationery in the first few months of the opening of schools and colleges, and this can be called as seasonal trend. Let us talk about next trend or variation, that is cyclical variations or oscillatory variations. This is a short-term variation, occurs for a period of more than 1 year. The rhythmic movements in a time series with the period of oscillation and repeated again and again in the same manner more than 1 year is called a cyclical variation, and the period is called a cycle. The time series related to business and economics show some kind of cyclical variations. One of the best examples for cyclical variations is the business cycle. In this business cycle, there are 4 well-defined periods or phases, which are: first phase is boom, second one is decline, third phase is depression, and fourth phase is improvement. Let us talk about next trend, that is called irregular trend or irregular variation. It is also called erratic, accidental, or random variations. The 3 variations trend, seasonal and cyclical variations are called as regular variations, but almost all the time series including the regular variation contain another variation called as random variation. This type of fluctuations occur in random way or irregular ways which are unforeseen, unpredictable, and due to some irregular circumstances which are beyond the control of human beings, such as earthquakes, wars, floods, famines, lockouts, etc. These factors affect the time series in the irregular ways. These irregular variations are not so significant like other fluctuations. Combination of the various components. Combination of various components. The value yt of time series at a time t can be expressed as the combinations of factors that can be attributed to the various components. These combinations are called as models, and these are of 2 types. Number 1, additive model, and number 2, multiplicative model. In additive model, where trend value at given time t, the seasonal component is equal to cyclical component is equal to irregular component, but if the data is in the yearly form, then seasonal variation does not exist. So, in that situation, generally the cyclical fluctuation have positive or negative value according to whether it is in above or in below the normal phase of cycle. In multiplicative model, the model can be put in additive model by taking log both sides. However, most business analysis uses the multiplicative model and finds it more appropriate to analyze business situations. Dear students, let us discuss the measurement of secular trend in time series. Secular trend is a long-term movement in a time series. This component represents basic tendency of the time series. And for this, we have one important method which is called method of least squares. This method is most widely used in practice. It is mathematical method, and with its help a trend line is fitted to the data in such a manner that the two important conditions are satisfied. Number one, that is the sum of the deviations of the actual values of y and the computed values of y is 0, and second condition is least, that is the sum of the squares of the deviations of the actual values and the computed values is least. The line obtained by this method is called as the line of best fit. The method of least squares may be used either to fit a straight line trend or a parabolic trend. Fitting of a straight line trend by the method of least squares. Let yt be the value of the time series at time t. Thus, yt is the independent variable depending on t. Assume a straight line trend to be of the form ytc is equal to a plus bt, and this is equation number 1, where ytc is used to designate the trend values to distinguish from the actual yt values. A is the y-intercept and b is the slope of the trend line. Now, the values of a and b to be estimated from the given time series data by the method of least squares. In this method, we have to find out a and b values such that the sum of squares of the deviations of the actual values yt and the computed values ytc is least. That is, S is equal to sigma yt minus yt whole square should be least. That is, S is equal to sigma yt minus ytc whole square should be least. That is, S is equal to yt minus a minus bt whole square sigma should be least, and this is equation number 2. Now, differentiating partially equation number 2 with respect to a and equating to 0, we get 2 sigma yt minus a minus bt multiplied by minus 1 is equal to 0, and this implies summation of yt minus a minus bt is equal to 0. This implies sigma yt is equal to sigma a plus b sigma t, and this implies sigma yt is equal to na plus b sigma t, and this is our equation number 3. Now, differentiating partially equation number 2 with respect to b and equating to 0, we get partial differentiation of s with respect to b is equal to 2 sigma yt minus a minus bt multiplied by minus t is equal to 0. This implies sigma t multiplied by yt minus a minus bt is equal to 0. This implies sigma t yt is equal to a sigma t plus b sigma t square, and this is equation number 4. Equation number 3 and 4 are called normal equations, and solving these two equations we get the values of a and b, and we can say a cap and b cap. Now putting these values in equation number 1, we get ytc is equal to a cap plus b cap t, which is the required straight line trend equation. Dear students, let us understand the regression and the time series. The time series models can be developed in a somewhat similar fashion to regression models. The observation yt at time t, where t varies from 1, 2 and so on up to 2, is regarded as the sum of two components, namely yt is equal to fixed component plus random error, where the fixed component in regression is called the trend. This model is called an additive model, as the fixed component and the random error add together. Another possibility is the multiplicative model yt is equal to fixed component multiplied by random error. This can be changed into an additive model by taking logarithms. However, the time series may have not only a trend, but it may also have a cyclic or seasonal component in the fixed part of the model. In contrast to the regression model, where we assume the random errors to be a random sample from a distribution, we now allow the errors in time series to no longer be independently and identically distributed, but to be correlated in some way. Analyzing a time series therefore requires some detective work to find out what components are in the fixed part of the model and what sort of correlation structure is in random or in error part. Both the fixed components and the correlation structure can be used for making predictions. Let us talk about moving averages model. If we are going to use a time series for prediction, we need to find any trend that might exist in the data, as trends tend to be obscured by the random errors. Some smoothing method is needed to iron out some of the ups and downs. The simplest way of smoothing a time series is to use a moving average method, which is based on averaging adjacent time periods. If we average the observations in pairs, then we average observations 1 and 2, 2 and 3, 3 and 4, etc., so that the average steadily moves along the time period. We effectively replace each consecutive pair by a smoothed value located midway between the 2 points, so that the smoothed series is out of phase with the original series. With the moving average based on just 2 observations, we may still get a lot of fluctuations and not enough smoothing. If we average the observations yt 3 at a time, that is average observations 1, 2 and 3, then observations 2, 3 and 4, etc., we will get a smoother curve. The more points we use to calculate the average, the smoother the curve we will get. Let us understand the forecasting time series and stochastic process. A time series is non-deterministic in nature, that is, we cannot predict with certainty what will occur in future. Generally, a time series xt, where t varies from 0, 1 to so on, is assumed to follow certain probability model which describes the joint distribution of the random variable xt. The mathematical expression describing the probability structure of a time series is termed as a stochastic process. Thus, the sequence of observations of the series is actually a sample realization of the stochastic process that produced it. Dear students, let us understand the ARMA model of time series. The ARMA or ARMA model have been specifically developed for the analysis of time series and are therefore much better suited to handle the dependencies in the observations than classical linear and non-linear regression models. Algebraically, the ARMA model can be written as yt is equal to b1 yt minus 1 plus so on, bp yt minus p plus eta t plus a1 eta t1 plus a1 eta t minus 1 plus so on, a q eta t minus q, and eta t is nid 0 sigma eta square. In the first part, on the right of the equal signs, the dependent variable yt is predicted by its own values shifted in time. In the second part, right of the equal sign, the dependent variable is predicted on the basis of the shifted values in the time of the residuals, and this is moving averages part of the equation. For a given time series, it is the task of the researcher to determine an ARMA PQ model specification that strikes a balance between a good fit and parsimonious use of parameters. Furthermore, it must result in residuals that satisfy the assumptions of and normality. However, an important requirement of ARMA or ARMA models is also their weak point. The analyzed time series must be stationary, that is, it must have a constant mean and a constant variance in time before the actual analysis can be carried out. Since time series in practice often consist of non-stationary components such as a trend or a seasonal effect, with ARMA models, the observations usually first need to be filtered. This means that the trend and the seasonal effects first have to be removed from the series by subtracting consecutive observations from each other in order to achieve stationarity. The actual analysis then consists of determining which ARMA PQ sets, which ARMA specification fits the filtered and stationary time series is the best. Dear students, the time series analysis comprises methods for analyzing time series data in order to extract meaningful statistics and other characteristics of the data. Time series forecasting is the use of model to predict future values based on previously observed values. Thus, we can say that time series analysis can be used quantitatively to monitor, to describe and explain as well as predict the values of variables, and thus time series analysis techniques offers the possibility of quantitative modeling in such a way that the dependencies between the observations of time series data are taken into account, and time series analysis techniques are surely and definitely meant for researchers in all fields where repeated observations measurements are carried out over time. Thank you very much.